All right, we got this part off of a Komatsu haul truck, and this is part of the piece that's still stuck in there that's wore out. It broke apart. Right now we're trying to get these bolts out. Eventually we're going to have to build this up and machine it back down. That's some of the part that we got to get out of there. We're going to set the camera up and show y'all our attempts to get out these broken bolts. Luckily they're all broken off not too far from the surface. This one right here might cause some trouble because the hole is egg-shaped, and then those might cause us some problems. All right, so we got all the bolts out. They all came out fairly easy. These ones over here were a little tougher, not just because they were stuck more, it's just because the weld started to overlap on the high side and it started binding, so we had to overcome that issue. Now I'm going to take the gouger and split this ring right here and get it out, and we'll see what we're going to do after that. All right, this hole's got a good bit of wear right here where the old one ran. You can see a little bit of wear right there. And this right here, this ring, it rides right at the top edge of this. So we got a good surface down there where it wasn't damaged. So that's a good surface we can indicate off of to line everything back up. And then we'll be able to bolt our top plate that goes here. We'll be able to bolt it on and indicate off the inside of that ring. So we've got two good surfaces that we'll be able to indicate off of, make sure we get this thing machined back square. And here is the old one that we had to gouge out. And that's what the new one looks like. And this gets a cap that he bolts onto here. And we're just going to, I'm just going to add weld. I'm not going to worry about welding these holes and drilling them. I'm just going to add weld around as close as I can to the edge of the hole, and we'll get this surface built up more than it needs to be, and we'll probably use our facing head to face this off back true. So that's what we're going to do now. We're working on getting the line boring mounts and everything set up. All right, we got our line boring gear, and I didn't video any of that, but I probably should have. We had this top plate bolted on, and that gave us a true center. So we didn't have to cone up on this worn section right here. And the bottom of this hole is still very true. But once we got everything, all this tacked on, then we put a dial indicator in one of these tool ports, or a test indicator. And in the bottom of that hole down there is still a good surface. You can see where the wear stopped right in there. All this surface right down in here is still good, and it's really good on this side. So we were able to indicate that surface. I have these mounts designed to where I can push this bearing around. The holes inside this piece of 1-inch plate right here, oversized, and then it just sandwiches this right here, so I can mount my drive motor on it. Something I come up with. But to me, this work needs to be done. Some of this work needs to be indicated in. I know people do it daily, relying solely on the cones. I feel like, for me, I like to indicate it in if I can. I don't like just going off the cones. So when this top plate was bolted in, we were able to indicate around that surface, and that's a freshly machined surface. So it gave us, now I feel very confident that this bar is lined up very, very close to where it was when this thing was originally made. We've got our drive motor bolted on the way so this is something I designed, and I've shared it with a few people. This locking collar, you'd call it, I made this, and this is a piece of heavy wall DOM tubing welded directly to this on the inside. And so when I'm pushing this bearing around, this is kind of traveling with it. So the biggest issue you have to work through when you want to do self-aligning bearings is you have to weigh the motor has to stay in plane with the bar. So when you slide this motor on, you have to have a way to attach it if it's out of square with this mount, which it is going to be out of square with this mount if you moved that bearing around at all. So I've got some locking screws. You can see where they've pinched in to that tubing, and I need to do a weld buildup on that and machine it off, give me a fresh start, because sometimes it'll you know, if you put it close to one of those little indentions, it'll kind of want to fall in it. But this is not a it's not 100% user friendly design, and I understood that it was going to be that way when I did it. This, you can pinch the bar if you don't watch what you're doing, and say you just tighten up on one of these, hammer down on one side. Well, then you're going to pinch the bar you're going to pinch the drive motor to the bar. So maybe this is not too confusing for y'all, but you have to tighten them up a little bit and then check it and make sure your bar's sliding good. If your bar's sliding good, then you proceed, you know, tighten a little bit around each one and then check your bar again and repeat that process. Now, if you pinch it, then you need to kind of go backwards and figure out which one you tighten too much. It's really not a complicated process. It takes a little bit of practice to figure it out, but it's just one of those things. It works very well with being able to mount this motor on the bar without the mount being square to the bar. That's kind of the best way to word it. I've been using this same setup for a while. These are some new bearings that I just bought. Those are some Dodge bearings, and I bought these because they have a concentric locking collar on them. That concentric locking collar is very handy in a situation like this. If you're doing any kind of facing and you need to lock the bar in position, the concentric locking collars are good. If your bar is really sliding through, your mount's really good, and you're doing an interrupted cut, it causes problems because the bar is trying to go too far forward when it's not in the cut, and as soon as you go in the cut, the bar kicks back. So if you have a way to put a little bit of drag on your bar, it keeps it at the same as it's going through there. It's not jumping back and forth like that. So that's just things that I've learned from doing it. Should be some helpful tips for y'all. The next step, we've got a lot of missing material here. I'm not going to worry. There's still plenty of threads. There's still plenty of threads in these holes that I feel like this cap retainer will stay on there, especially if they do some Loctite where they won't back out. So I'm going to TIG weld around each bolt hole as close as I can. I don't really feel like it's necessary at this point to try to weld up those holes and try to reestablish them. And I'm just going to do a weld build up. We're going to get it. This right here is good. This surface is really nice. No wear on this. So I'm just going to take the weld build up from this point and probably about right in here. We're going to do a weld build up, and I've got this set up to where we can run the facing head. And so once we get it all built up, we're going to do a layer of weld on the inside because it's shot, and we'll face it off to where it'll be perfectly in, square with the hole, and that retainer cap will set on there like it's supposed to. So that's the next step. So right there, I can see I just barely welded it. I'm gonna see if I can get it to break loose. Just barely rubbed up against the bolt. Anytime I'm doing something like this, I'm always going to want to put way more than what it looks like you're going to need. You always, seems like if you just put like, if you stop where you thought it needed to be, you'd always be low. So I just always go a few extra. All right, so we are working on getting the last bolt hole that's got some wear finished up. And all these I use just regular mild steel to 70S2 to get it built up. And I drop a bolt in there. I didn't really know how it was going to work out, but that kind of gives me a visual representation of how close I can get that weld right there to it before I start causing problems. And everything went so pretty good. I did just barely touch it, you know, to the threads here and there on some of these, but you can kind of see when you do that. And when I did, I just put a ratchet in there and broke it free and went back to welding. At least I was getting it as close as I could. But sitting here thinking that I was going to try some silicon bronze. I've got some 1/8 silicon bronze wire that I keep and use a good bit for different things. It's kind of a handy wire to have. But the silicon bronze wire, the beauty of it is it's got a very, very low melting point. So it will melt before your base metal, you know, really gets to the point to where it melts. But so I started kind of running a butter bead, you know, the first one to get it attached to this part good. And then I just started dragging over the top of the wire, and it was really hugging the threads nice. And like I said, the low melting point, the wire was able to melt, but it really wasn't enough heat coming off the tungsten to burn these threads up like the carbon steel wire was. So it's been a good idea to do all these with the silicon bronze, and I'll come back over the top of this with some 70S2. That way everything, you know, it's still the silicon bronze is still hard enough for this application for sure, and it welds fine to the mild steel, but thought I'd share that. I'm gonna come back in here with some hard wire, just regular hard wire MIG, and fill in all these low spots. And then I'm gonna do a pre-cut on this board. This is a good bit of wear right here, and on this side it's got some wear. So I'm gonna do a pre-cut down to this surface here, and then we're gonna come up with the bore welder. I'm gonna make sure I don't get into this surface here with my pre-cut, and I'm gonna start it right there at it with the bore welder, and I'll still have a visual representation of when I come back down to that when I'm machining it out. That way I don't lose that distance from the top side of this to the bottom of that step. So that's where we're at. Gonna finish this up, weld in these with hard wire, get all this built up with more material than I know I need. We're gonna pre-cut it, and then we're gonna bore weld it and do a final machine on it, and this project will be wrapped up. All right, we got the hole welded up. I threw in some smaller bolts just to sit in there and cover up the hole so we didn't get any spatter in there. And we're gonna let this cool off, and we'll start machining on it, put our bar back through there. And we use the larger HTP machine. This is what we normally use for our general fab and just shop repairs on most things. This one's got dual drive rollers in it, so it does very well. And the bore welding equipment that we use has the European style connection, so it's just as simple as plugging it right in. I can't say enough good things about these HTP machines. They just work very well, and you get a lot of value for the cost of them, I feel like. All right, we just did our first cut knocking off some little high spots we had. Didn't get it all the way cleaned up. One thing that I like to do is I set this, when this carbide right here touches this height gauge, that means I am about 60 thousandths away from final size. So it just gives me a quick and easy way to see how far that tool's sticking out, and lets me know when I'm very close and I need to start measuring the actual bore instead of just measuring the stick out. That's the process I use for this. So I just ran it out a little bit more, and probably 2 more times to get to our tip of the height gauge. For the most part, when we measure these holes with the bar in the center, we use spring calipers, and then we take that and reference it into a micrometer. And it's kind of intimidating at first when you start measuring like this, but it's very accurate once you get a little bit of time doing it. So Caden's working on his skills today, getting a better hand for it. It's one of those things that just takes doing. You can watch all you want, but you just have to spend the time focusing and practicing on it. We set up a micrometer. We like to use these wooden Jorgensen clamps just to hold the micrometer vertically, and we'll, put the spring calipers and sweep it, adjusting the thimble on the micrometer till we get the feel that we're looking for, and then we'll take that measurement. All right, we're fixing to make our final cut on this, and then once we get the bore cut to size, we'll start getting the facing head set up to machine off that weld on the top there. All right, here it is all finished up. We just had the cap sitting on there, and those bolts are just hand tight. I was gonna let the mechanic that's gonna install this make sure he likes everything and don't know if he wants to put Loctite on those or not. So everything went pretty smooth on it. Ended up getting the face cleaned back up and got that weld as close to the bolt hole as I could, and didn't run into really any issues there. The bolt started pretty good. Here's all the bolts. Some of the bolts we had to get extracted. All 10 bolts were broken off in there. And here's the bottom of this part right here that we gouged out. Get this thing cut off the table in the morning and figure out what we're gonna get into next. But hope y'all enjoy this video. I know the line boring videos, to me, if you're really not into line boring, I feel like they could be kind of boring. But for those of you who are into it, and you know, I learned a lot of this stuff on my own. There's been some great people out there that I've met through social media that are willing to share advice with me. But for the most part, my opinion is, if you want to get into this work, just get into it. You know, take people's advice lightly. Everybody's got their own opinion. There's people out there that's done this work their whole career, and they might not be the kind of people that are going to easily tell you that you can get in it and learn it yourself. But if somebody does tell you that, just understand and know that that's false information. I don't claim to be the best line borer. I definitely learn every day. I make mistakes. I've made big mistakes. But I can tell you that I come from a welding background, very intrigued in machining. Did a little machining in my shop, nothing major, but it's something that if you want to learn it, you can learn it. So if there's people out there telling you you don't have enough experience, this and that, just take it with a grain of salt. If you're committed and dedicated to any kind of work, you'll be able to do it. But I will assure you that I misunderstood how much work went into this line boring work. It is more labor intensive than I thought. It's not. People think it's just watching a machine go round and round and watching a welder go round and round. I assure you there's way more to it than that. But it's the kind of, like I've mentioned before, it's the kind of work I've got into. I don't plan on getting out of it. And so I try not to complain about the hard times, but it is a struggle. It is a struggle to go out on site and do line boring work out of a truck and just hoping you have everything you need to do the job. It can be very tough at times. It can be stressful. People don't think it's stressful. It's mentally exhausting, I feel like, sometimes for me. But anyways, I hope y'all enjoyed this video. We're gonna keep doing our best to keep putting them out, and y'all just keep commenting and keep liking them. We'll keep putting them out.